We'll continue with chapter 5, section 5. This will be the last section you will learn in this course, Calculus 1. So let's learn the substitution rule. So you are given a function u which is g of x, and this function u is a differentiable function. You can differentiate this function whose range is an interval I, and the function f is continuous on I. So f is a function of g, composite function, and you have a derivative of g here, which is g prime. So integral of such functions is just fu du, which means you will be replacing u as g. So differentiate this u. So when you differentiate this u, you have a du. When you differentiate the g, you have a g prime x dx. So this g prime x dx is written as du, and this gx is written as u here. So the messy integral is rewritten as a simple integral when you do the right substitution. So let's do this. Evaluate the integral by making the given substitution. So you are given a substitution here. So let me write that here. Step 1, u equal to negative x. Let me differentiate u, it is du. Let me differentiate x, it is dx. So this du dx you will see in every problem of differentiation if you have assumed the substitution as u. Now let's differentiate the number in the front of u. It's 1, so you write 1 here. Differentiate this, it's negative 1. So this was your step 1. In the step 2, you will write the given integral e to the negative x dx, and you will plug these here. So I'm going to rewrite this as integral e to the negative x is u, so the numerator, the exponent becomes u. Du is negative dx, so you can write dx as negative du. So this becomes du, the negative goes out. Integral of e to the u is e to the u, so write the same, and a constant of integration plus c. So maybe you want to make a note of this formula. Integration of e to the ax dx, a is a constant. It is e to the ax divided by a. If a is a constant which is 1, like the example what we did just now, this will be just e to the x. The next one, you have a cubic function multiplied with a degree 5 polynomial. So you're also given a substitution. So let's use this. In the step 1, I will write the substitution u equal to 2 plus x square. And I'm going to differentiate this. By default, differentiate u, it's du. Differential of the right hand side is a dx variable. Now the u variable will always be du, because in the front you have 1. When you differentiate it's 1, you're not going to write 1 there. So it's understood. When you differentiate 2 plus x square, all you have is 2x. So you have du equal to, I think it was x to the 4. The problem we have x to the 4. So it's 4x cubed. So let's calculate a substitution for x cubed dx from this. So I'm going to write x cubed dx as du divided by 4. Now let me write the question, the integral which we want to evaluate, x cubed 2 plus x to the 4 to the 5 dx. So we know that all these terms here, this is what was assumed as u. So I'm going to write this as u to the 5 integration. And this x cube and dx combined, here we have this expression which is du divided by 4. So I'm going to write it as du divided by 4, 1/4 goes out. Integrate this, this will be 1/4 u to the 6 divided by 6 plus c, where you want to write u is what you assumed in the starting, 2 plus x to the 4. The next one, you are given an assumption that, like a substitution, u is 1 minus 6x. Step 1, Write the assumption given 1 minus 6x. Differentiate du is dx. Differentiate the coefficient of u, which is 1, it's 1. So you don't write that. Differentiate 1 minus 6x. It's negative 6. So you write du divided by negative 6 equal to dx. You will use this. So rewrite the integral you want to evaluate, dx divided by 1 minus 6x to the 4. So you want to rewrite this. I'll be using these plugins here. Dx, the numerator will be du divided by 6. The denominator is u to the 4. So take out all the negatives and the constant outside and move this u to the 4 to the top. So this looks like this, u to the negative 4 du. Integrate this, we have u to the negative 3. As soon as you integrate, you will not have the sign of integration. And then you write this as u to the negative 3 divided by negative 4 plus 1 is negative 3 divided by negative 3 plus c. Simplify, you write this as 1 over 18 u to the negative 3 plus c, where you write that u is whatever you assumed, 1 minus 6x. In the next example, you are asked to evaluate the integral x times x squared. So from this example, you are not given what is a possible substitution. You have to assume the substitution. So let's try by assuming x squared equal to u. So this is something what we are assuming. So you can write let x squared equal to u. Now let me differentiate the right hand side, you get du. Differentiate the left hand side, by default you get a dx. So differentiate x squared, you get 2x. So now you can write x dx is du divided by 2. So rewrite this integral, integral x sine x squared dx. Rewrite all the substitutions. So this is integral, this x squared is assumed to be u. So write this as sine u. This x and dx combined is du divided by 2. So take this 1/2 outside. It's 1/2 integration sine u du. Integral of sine is negative cosine, so write negative cosine. It was the variable u, so do write the variable u itself. Plus c, where you can finally write where u is x squared. That's what we assumed in the starting. The next one, sine ln x divided by x, and we are integrating this function. So let's assume u is ln x. So du will be 1 over x dx. Plug these back in the integral. Your integral looks like this. Sine u du. It's very simple. Integrate, you have negative cosine u plus c. The next one, e to the x divided by 1 plus e to the x. Assume u is 1 plus e to the x. Differentiate. Du is 1 plus, differentiation of 1 is 0. Differentiation of e to the x is e to the x. So it's e to the x dx. Plug these back here. Rewrite the integral. The numerator is just du. Denominator is u. So this is ln u plus c, where u is 1 plus e to the x. So a correct substitution will lead you to finish the integral problem, but if we mess up with the substitution, that will lead to an integrand which will not be still integrable. So you have to choose the best integral substitution which will work for you. So the next one is substitution rule for definite integrals. The only difference is you have limits here and you did not have this limits before. So you do usually like the way we have done before, but in the last step evaluate the limits. So let's do that. So come up with a substitution. Say u equal to ln x, then du will be 1 over x dx. So when you plug these back, you can rewrite the integral as e to the 4, the numerator is du, denominator is square root u. So you write it as e to the 4, take the square root u to the top, u to the negative half du. Integrate, you have u to the negative half plus 1. U to the negative half plus 1 is 1 half divided by 1 half e to the u. You might be tempted to plug in u as e to the 4 and u as e, but you have to be very careful that e is the limit for the variable x, not the u. So you can change the limits by calculation, or you can change the variables. Let me change the variables itself. This is an easy task of changing the variables and plugging in rather than recalculating the limits for the new variable. So let me write u is ln x, and I have a square root 1 half, and then divided by 1 half, and then I have a limit e to the 4. Now I can say that these upper limit and lower limit belong to the variable x. I can plug in upper limit minus lower limit. Simplify and you will see that you get an answer too. So when you have a definite integral and you're doing a substitution, make sure to change the variable in the last step, and then you will plug in the limits. One last example, a bacteria population starts with 300 bacteria and grows at a rate given by this expression. And this is the rate of the bacteria is the number of bacteria per hour. How many bacteria will be there after 3 hours? So first come up with a unknown term here, which is n. How many bacteria? So you're counting the number of bacteria. So write n of t equals the number of bacteria per hour. N at 0. Initially you had 300 bacteria. You're asked to find the bacteria after 3 hours. So n at 3 is your question. You want to find n at 3. You also know that the growth rate term is given for you. RT is the growth rate. And you have been given that this is 450.269 exponential 1.125670. But it's going to be very messy if we start differentiating or integrating with these big decimals. So we will rewrite all these messy decimals to some variable, say a exponential b, and then you have a variable t. So this rewriting part should be only for this messy decimals. The first messy decimal is a, the second decimal is b. Now that we have expressions and definitions for the number of bacteria and the rate, you know that integral of a prime, integral of a differentiation term is just the term itself. So let's do this. Let me write n prime, which means it's the rate of change of number of bacteria, which is n prime t, equal to RT, which is the rate expression. You want to read this n prime as rate of change of number of bacteria, which is n prime, which is equal to the rate term RT. So now you want to integrate both these expressions. So let me write integral n prime equal to integral r. But whenever I write integration, I should write the variable of integration, which is dt. Now integrate the left hand side. Integral of n prime is just n, and the limits of integration in both the case will be 0 to 3. So let me write 0 to 3, evaluate from 0 to 3, equals integration of 0 to 3. For r, the growth rate term, we have an expression given. It's a e to the bt. We rewrote the messy terms as a and b dt. So let's integrate the right hand side. A is a constant, it goes out. Integral of exponential is the same, divided by the exponent b. Evaluate this from 0 to 3, and then you have n at 3, the upper limit, minus n at 0, the lower limit. So we have n3 minus n0 equals a exponential bt divided by b. Evaluate this from 0 to 3. Take this n0 to the other side and we know its value. It's actually 300. So I'm going to write this as 300 plus. I have a constant a over b. Do the upper limit minus the lower limit. Upper minus lower. When you simplify the upper limit, it is e to the 3b. Lower limit e to the 0b. E to the 0 any expression is 1. So you rewrite this as 300 plus a over b e to the 3b minus 1. Now that you're almost done, you're good to plug in the a, b values. You don't want to simplify further, so you're good to plug in where a is 450.269, b is 1.12567, e to the 3b, 3 is 1.12567, and then you have this negative 1. So the number of bacteria after 3 hours will be this much. This is a really big expression and it would have been a very messy problem if we did not rewrite the constants a, b rather than those messy decimal expressions. So this was a nice application problem. So we did learn the substitution rule in this section, and this will be the last section in this Calculus 1 course. So we'll end this lecture here.